Thank you. Thank you. Okay, hopefully I can remember how to work this. So I gave a talk here at Astronomy on Tap about a year and a half ago, I think, and it was actually on more related to research I'm currently doing, which is on galaxy formation and evolution. But so today I wanted to do something a little bit different, and I don't think I need to reintroduce myself. If you don't remember me from 30 seconds ago, I think I might tell one of our bartenders to cut you off. But yeah, so today I'm going to be giving a talk on hidden figures, untold stories in astronomy. Down is next. Okay, so if you're wondering why I'm giving this talk, so obviously I was a bit inspired by the movie Hidden Figures, which highlighted 3 black women mathematicians who worked for NASA. And I just wanted to shed light on some lesser-known astronomers who I think deserve recognition for their amazing work. Yeah. I mean, we all love our Galileos and our Carl Sagans and our Einsteins, but there are other people doing great work all around the world that maybe just don't get, their spot in the limelight. And also, as A. Lee mentioned earlier, this talk was actually requested by one of the audience members, and I do hope they are here. But yeah, if this is something that more folks think is interesting, I would love to kind of make a series out of this if there's enough interest to try and, because I have a list now, like over a page long, of all these people that I could talk about, and I would love to highlight them at some point. All right, but since I only have about 15 minutes, I'm only going to highlight 3 people for tonight's show. If you have heard of all 3 of these people, I will be very impressed. Come talk to me after. Basically, the criteria for this to be was just that I wanted to get a broad span of time, so people throughout history, and then I also wanted to highlight people from around the world. So for tonight's Hidden Figures, we have Hypatia. We have Guillermo Otto, and we have Mercedes Richards. So we'll go in chronological order, and we'll start with Hypatia. So Hypatia, the time of her birth is a bit disputed. Actually, let me do a little disclaimer beforehand. I'm not a historian. Like I said, I study galaxy formation and evolution. Also, all the work that these people do is not my field of expertise. This is just what I've compiled in my free time. So be nice, please. Okay, but going back to Hypatia. So yeah. Time of birth, a bit disputed, between 350 and 370 AD. She's often called the first female astronomer, or also the first female mathematician and first female philosopher. Now, this is based on written record, so there may have been people before her that we just don't have a written history of. So Hypatia was born in Alexandria, Egypt. She is the daughter of Theon of Alexandria, who was, maybe not so surprisingly, also a mathematician, philosopher, and astronomer. So you can imagine where she got her first introduction into these topics. So Theon wanted to make sure his daughter had a great education, so she also was sent to Athens for a while to continue in her schooling. Hypatia was also a Neoplatonist, which I won't really get into what the details of that means, but just think that in the time of Alexandria, Egypt, the main religious factions were Christianity and Judaism, and Neoplatonist is not one of those, so therefore she was considered a pagan by people in Alexandria, which will come more into play later in her story. So in terms of her contributions to astronomy and science in general, one of the biggest things that she contributed that most scholars seem to converge on is her contributions to Ptolemy's Alchemist. So she was thought to have edited and added commentaries to this massive work that Ptolemy put together, which covered everything from cosmology to eclipses, solstices, the movement of the stars, or the movement of the planets and the moon. It also had a star catalog with over 1,000 stars on it. And in particular, what people seem to agree on is that she edited significantly Book 3, which covers the length of the year and the motion of the sun. And one of the reasons the Alchemist was so important, and in particular this motion of the sun, was that it solidified the idea of the geocentric model of the universe, in which it was believed that the sun revolved around the Earth. And while this model is incorrect, it proved to be very important that people accepted this geocentric model for the next 1,200 years, which is an incredibly long time for a theory to stand, and everyone still agree with it. So yeah, it wasn't until Galileo and Copernicus came along with the heliocentric model and actually proved, no, the Earth revolves around the sun. She also had some commentaries on conics and arithmetic, which are other kind of classic works, mostly dealing with math, which I won't get into because math, ugh. She was also said to have constructed plane astrolabes, and an astrolabe is used by astronomers and navigators to find stars in the sky, and they're used for navigation. You can use them to triangulate. You can find the latitude where you're at on the Earth if you give the local time of day. And initially, astrolabes were these big, chunky, spherical orbs, and Hypatia constructed, she didn't invent the plane astrolabe, but she learned how to construct these plane astrolabes, which were much more portable and useful for people. And then she taught others how to use them as well. So Hypatia was a renowned lecturer in Alexandria, specifically on the writings of Plato and Aristotle. This upper right image is her in the middle, just surrounded by a flock of others just waiting on her, you know, listening to every word, trying to figure out what she's saying. And so yeah, she became really well known for her public speeches and her public lectures, mostly on philosophy. But during this time that she became so popular in Alexandria, there arose a conflict between Orestes and Cyril. And Orestes was the governor of Alexandria, and Cyril was the head of the main religious body in Alexandria. Basically, the conflict between the two of them resulted in many deaths of Christians and Jews, and there's more to the story, but basically, Orestes was quite fond of Hypatia. He went to her a lot and appreciated her philosophical thought and all her thinkings. But unfortunately for her, rumors spread that she was preventing Orestes and Cyril from coming to some reconciliation and bringing peace to Alexandria. And so in the end, a mob of Christian zealots led by a man named Peter the Lector snatched Hypatia in the middle of the day, drug her across the town, and murdered her, you know, because they wanted peace. I don't But there was a lot of kind of gruesome details or thoughts of how she was killed. The main convergence was that they stoned her to death with roof tiles, which sounds just like not a nice way to go. So yeah, the bottom image is depicting that whole scene. So unfortunately, if you've heard of Hypatia, it might be more because of how she died rather than the great things that she contributed when she was alive. But so we're going to remember her as Hypatia the astronomer and mathematician and philosopher. All right. So that's Hypatia in a nutshell. Yeah. All right. The crowd is really into it tonight. I appreciate this. Okay, moving on. We have Guillermo Otto. So he was born on March 21st of 1913 in Mexico City. Guillermo actually had a bit of a different path to astronomy, a kind of non-traditional path. He actually studied philosophy and law at the National Autonomous University of Mexico, and he then became a reporter for a local newspaper. And it was as his time as a reporter that he became interested in astronomy after he conducted an interview with Luis Enrique Haro. And Haro was, at the time, an amateur astronomer, but part of the administration of the current president of Mexico at this time. And with the president of Mexico, they created the Observatory of Tontanzila. I hope I'm saying that correctly. So he actually made Guillermo an assistant at the new observatory that had just been built after he expressed interest in astronomy. And then from there, Haro arranged for him to further his astronomy training in the United States, first at Harvard College Observatory, then at the Case Observatory, then at the Yerkes Observatory, and then finally at the McDonald Observatory. Yeah. And he was there between 1945 and 1947. And so another reason I wanted to include him was his involvement in our West Texas Observatory. I know a lot of people in the audience really love McDonald and those beautiful dark skies out there. So yes, in terms of his scientific contributions, has anyone heard of a Herbig Object? Yeah, a couple people. Okay, good. Here's a schematic of what this object is on the left. So basically, if you have a newborn star that is formed from a nebula of gas and dust, the star forms. It has an accretion disk of gas around the star. This gas and dust may fall into the new formed star and create these jets that shoot out from the poles. So these jets are ionized gas. They're moving pretty fast and basically scooping out the rest of the nebula and interstellar medium that it interacts with. So what you end up with as the jet shoots out, it hits the ISM, or the colder nebula that's in between the star and it. It creates a shock front, and basically this bow shock that's created from the jet interacting with the ISM is the Herbig Object. So here's a couple examples from the Hubble Space Telescope of this. I actually thought this middle one was an artist rendition when I first saw it, because I was like, that is pretty. Okay. So basically you have the newborn star here in the middle, and these jets shooting out from either end. And the jet is not a continuous jet. It's kind of goes in clumps, you know. It's irregular. So you can see as the material meets the ISM, you get these kind of shocked regions, these bow shocks. And here's another example on the right with the star in the middle again. And yeah, the jet's coming out, and you get these kind of arc-like structures as the jet interacts with the ISM. So these are really cool and pretty objects, and I encourage you to look them up because there are a lot of examples of them. In terms of other major accomplishments and the legacy that Guillermo Haro left behind, he's actually the youngest person to become a member of El Colegio Nacional at 40 years old, and that's a very prestigious academic institution in Mexico. It's also, they're pretty strict on the rules of who gets accepted and stuff, so it's a big deal in Mexico. He was also the first person from Mexico elected to the Royal Astronomical Society, which is based in London, England, and comprises of a large number of professional astronomers, and possibly the biggest contribution, or at least today, of the Royal Astronomical Society is that they publish an academic journal called the Monthly Notices of the Royal Astronomical Society, which I think many astronomers in this room have submitted their papers to. So that's a big deal. And then lastly, or one of the other things, was that he actually had a galaxy named after him, which is this galaxy on the left, which is called Galaxy Otto 11, and it was named after him because he was the first person to mention it in one of his studies in 1956, I think. It's in my presenter notes, but I can't see them. So yeah, that is, in a nutshell, Guillermo Otto. All right. And last but not least, we have Mercedes Richards. So Mercedes Richards was born May 14th, 1955 in Kingston, Jamaica. She earned her Bachelor of Science in Physics from the University of West Indies and her PhD in Astronomy from the University of Toronto. She became faculty at the University of Virginia and was there between 1987 and 2002, and she became a full professor there in 1999. She then actually moved and was hired as a professor of astronomy and astrophysics at Penn State University in 2002. So, in terms of her awesome research contributions. She's most well known for her contributions to computational astrophysics, stellar astrophysics, exoplanets, and brown dwarfs. She is credited as the first to use tomography in astronomy, and I would guess that actually a lot of you kind of know about tomography even if you've never heard that word before. If you think of a CT or a CAT scan, CT stands for computed tomography scan. So in a CT scan you have you're in like a little tube, and all these x-rays are coming in from all angles around you, so they can take cross-sectional images of your brain and get like a full 3D picture of what's going on in your brain. But with a star, if you're looking at a star, we're only seeing it from one angle. We can't go all around the star to take images. But luckily the star does most of the work for us, in that all stars are rotating in some degree. So if you just take many images as a star is rotating around, you can still get this same kind of 3D image of what's going on. So then if you add in a binary, so you have two stars rotating around each other. So here is a movie of the binary star. You can see, in this case at least, that it kind of looks like at some points the binary star that's moving around the central one is kind of attaching or kind of globbing onto the central one. And so in this case you can use what's called Doppler tomography. So as the star is rotating, one hemisphere is rotating towards you and being blue shifted, and the other hemisphere is rotating away from you and being red shifted. And Mercedes used this idea of Doppler tomography and binary stars to map the flow of gas with the redshift and blue shift between between the binary stars. So she had already modeled this idea that there could be gas flow and kind of a transaction from one star to the next in a binary system, and this imaging technique kind of confirmed that, and she was able to enhance her models even further. So she was and here's a schematic of what's happening down here. So you have a kind of puffier giant star, and the material is then accreting onto the companion star. So she was a pioneer in making theoretical hydrodynamic simulations of the algal binary stars, which is what this movie is of. And I encourage you to look up the algal paradox, because it's kind of a cool, funky thing that happens with binary stars. All right, so in terms of her professional career and legacy, she was a member of the International Astronomical Union, which I think might be like the largest body of astronomers in the world. It's broken up into divisions, commissions, and working groups. And so she was president of Commission 42, which is specifically on close binary stars. If you're wondering why there is a picture of Pluto here when we're talking about her work on binary stars, she was actually at the 2006 IAU meeting in Prague, in which they voted on and decided that Pluto was no longer a planet. And I know we have she could have voted no. That information is not public. So we don't know, but it would have been fun to hear her perspective on how that meeting went, because I don't think everyone is happy with the decision. Yeah, you're right. So she received the Fulbright Distinguished Chair Research Award in 2011, which she then used to continue her studies on binary stars in Slovakia. She also organized the first joint international meeting between binary star specialists in 2011. So she was really involved both internationally and nationally in promoting astronomy, increasing diversity, and I was unfortunate in that I never got the chance to meet her, but I know people who did, and they all only had wonderful, lovely things to say about her. So those are our 3 hidden figures for the night. Thank you very much. As I mentioned before, please let me know if you want to hear about more. I have plenty more that I could tell you about, and I will do my best to answer any questions you might have. So thank you very much.
All right, let's try a few questions. Any history buffs? Yes, in the back.
Awesome.
She passed away in my 50th year.
Mm-hmm.
I just want to thank you for mentioning her here.
Oh, awesome. Thank you.
All right, any other questions? Shout outs.
It's kind of a weird talk to have
Yes.
questions for. I understand. It's okay.
Right. Yes.
Do it again. Okay, that's what I love to
Okay.
hear. Okay. Oh, the question was, after all the research I've done, do I have any intuition or thoughts on why these folks in particular maybe fell out of the spotlight? Oh, God. I mean, there are plenty of kind of structural reasons behind why they might not be recognized. I mean, women alone weren't really included in astronomy for quite some time. People of color even longer, right? You know, that could be a whole other thesis, maybe. But yeah, and then there's an issue of personalities and who's popular and who gets kind of accepted as the main voice. Who's speaking the loudest. Yeah, that's a difficult question to answer. Nothing particularly that I read said anything as to why they wouldn't be recognized. But yeah.
All right, balcony questions. Yes.
Anyone? When the question was, when is Pluto expected to make a full rotation around the sun? Kepler's third law. Do some mental
Figure it out.
math. I'm sorry, I'm not a solar system person. There you go. It's not a planet. We don't care.
Was there another one in the top, or were they just okay? Anyone else? How about here up front?
Oh, yeah. No, I had a very similar question. So the question was Hypatia actually Egyptian? The depiction of her and the things that I read were that she was quite fair. Egyptian, you might think, is not so fair. But it was also after a time of the Roman Empire was in control of Egypt at this time. So I would imagine Romans had come down and kind of established themselves. And also Alexandria had also already gone through several bouts of turmoil and uprising. Again, I should go back to my classics class in college and figure this out. But I think the depiction of her is more or less okay. Yeah. Yeah. Did you want
250-ish years, I think, is the period of Pluto.
Wow. Okay. Good job.
Someone, well, if I'm wrong, don't confirm that. But if I'm right, confirm it. How about right here up front?
Sure. Yes, I did read about that movie. Yes. Uh-huh.
Set it up, it's not historical, but they set it up like she just had this insight that, wait a minute, the orbits aren't circles, they're ellipses.
Yeah.
And then she got murdered.
And then she got murdered. It's like, who knows what we could have had if they just didn't murder her? Gosh. Yeah, I've read about that. There's a movie starring Rachel Weisz. It's called Agora, and she is Hypatia in that movie. I don't know how historically accurate it is, but I've heard it's a good movie, so worth checking out.
All right, maybe one more question. How about right there?
I would love that. I would absolutely love that. So the question was, am I aware of any conversations that are tending towards a place in time where we could be at where we don't have to have a hidden figures discussion anymore? Is that more or less what you said? Thank you, sir. He said if we deal with institutional racism first, then maybe we can get to that point. Yeah, I don't know if I see that time converging soon. But I hope talks like this, and I know a lot of people are doing a lot of great work similar to this in terms of getting the word out on all the people around the globe doing astronomy, that at least they'll become more visible, and there won't be a certain image that people think of when they think of scientist or astronomer. Yeah.
With that, let's thank Sinclaire Manning again.
You.